Blake McHugh. I'm attempting a video reassessment for Standard 3. This is my second video reassessment. The first one I had labeled as Standard 2, but I saw that it does more. The question did more relate to Standard 3. But my question is from Chapter 3, Number 21. To get to a concert on time, a violinist must drive 122 miles in 2 hours. A. If she drives an average speed of 55 miles per hour due west for the first 1.2 hours, what must her average speed be if she drives 30 degrees south of west for the remaining 0.8 hours? And B. What is her average velocity and direction for the entire trip? So the first thing we're going to do here is we draw a graphical representation. You can see right here she drove west at 55 miles per hour for 1.2 hours. So first we need to get that in miles. So we have 55 miles per 1 hour equals X miles per 1.2 hours, and that comes out to 66 miles. Okay, so she drives 66 miles in 1.2 hours. She needs to drive 122 minus 66 that she already drove, which is 56 miles, in the remaining 0.8 hours, or 48 minutes. So what I did is, instead of going to miles per hour, I went to miles per minute. So 56 miles per 48 minutes. Did a conversion factor, 60 minutes per hour. Your minutes cancel. And you're left with 70 miles per hour is what she needs to drive in order to get to the concert on time. For question B, what is her average velocity with direction? First, we have to find her displacement, and we're going to find that as a vector quality. So you can see here, I redid the graph, and we got distance 1 and distance 2, which we know. Theta, we know theta. Okay, and I just labeled. I made a right triangle out of this, and I labeled my legs as X1 and X2. Alright, so it travels west at 188 degrees for 66 miles, then 30 degrees south of west for 56 miles. Theta equals 30 degrees. Distance 1, again, this is in a vector quantity, so it's negative 66 x hat miles. Distance 2, we don't have a vector quantity out of that yet, so it's just 56 miles. Okay, so first we have to find x1, which x1, I know that's going to equal sine theta, and sine theta is going to equal, x1 is going to equal sine theta equals x1 over distance 2. So that's sine 30 equals x1 over 56. Sine 30 times 56 gives us 28 miles. And we know that's traveling in the negative y hat direction. Okay, x2. We know x2, that's going to equal distance 2, which equals x1 squared plus x2 squared. Okay, so we know distance 2 and x2. We know distance 2 and x1. We're trying to find x2. So that's 56 squared equals 28 squared plus x2 squared. We solved that for 48.5 miles, and that's in the negative x hat direction. So to make a vector out of these, we need to subtract our distance 1 minus our distance 2. And so we got negative 66 x hat plus 0 y hat. That's going to be our distance 1 as a vector, minus 48.5 x hat minus 28 y hat. That's going to be our distance 2 as a vector, and then we get negative 114.5 x hat minus 28 y hat. And so from there, we need to set that up as a right triangle. So we know we're going 114.5 degrees in the negative x direction. 114.5 miles in the negative x direction, and then we're going down 28 miles in the negative y direction. And so from right here, theta is going to equal our direction of displacement, and our hypotenuse is going to equal our distance of displacement. So in order to find our hypotenuse, we know we got 28 squared plus, or the square root of 28 squared plus 114.5 squared, and I found that to be 117.9, and that's going to be in miles because both of these are in miles. Our velocity average is going to be our distance divided by our time. This is going to be our distance, our 117.9, and our time is still going to be 2 hours. To get that in a quantity of miles per hour, we just divide the two, and we get 58.9 miles per hour. Okay, that's our, I guess that'd be our magnitude, but that wouldn't be our direction necessarily. To find our direction, we have to find theta. We know our cosine theta is going to be 114.5 over 117.9, so theta is going to equal the inverse cosine 114.5 divided by 117.9, and we get that to be 14 degrees, and that's going to be in a south of west position.